Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 22 of the March Daily LeetCode Challenge, and we again have a medium question in front of us. Yesterday we had a very good question. It was on the topic, if you see other yesterday's question also, like please go through that video. So in that we were doing the topological sort, okay? So it's a very good question. I will definitely expect you to go through that because in today's question also the ideas that we are going to use is coming from the concept of topological sort only, okay? The same thing, we'll create a graph, we'll create a in order dictionary. Based on that we'll be finding out today's, we'll be so using them to solve today's question as well, okay? So again, same thing, I expect that you go and read the question once and then come back, because you should have the clarity. Because whenever it's a graph question or dp question, I always request you to go and understand it once, okay? Because see, if I start explaining everything, it will be very difficult for you to understand. Because see, this theory concept, it's something that you have to read and you have to understand, okay? Now, in coming to this question, see, there are two important points. The first point is the connected component definition, and the second point is the definition of the complete, okay? A connected component is called complete if there exists a edge between any given pair of vertices, okay? So again, let us go through it. See, we have in example number one, if you see, we have this component 0 1 and 2, okay? First of all, what is a connected component? Connected component means it's just kind of a subgraph, okay? In a whole graph, let us say your graph has, in this case, here n equal to 6, okay? So here the nodes are from 0 to 5, okay? So the number 0 1 and 2, the other you're saying, okay, it's kind of a subgraph in the whole graph, okay? Subgraph means if you see this particular graph, okay, it's acting as a component. That means it is not connected with the other elements, okay? For example, 5 is not connected with this component, okay? Similarly, 3 and 4 are not connected with 0 1 and 2, okay? So 0 1 and 2 in itself is acting as a separate isolated component, okay? That's why we are calling it as a connected component, okay? You can go through the definition of the connected component. But what they're trying to tell you is that, see, obviously there is a well, the basic definition of connected component is that each node in this component should have at least some path to reach every other node in this component, okay? That is a basic definition behind a connected component. And obviously they are saying that there cannot be vertex from which there exists edge to any other component of the graph, okay? So obviously that means, okay? So it's, I hope the definition is clear to you. We can imagine what is happening, but should be able to explain also what is a connected component. The idea here is, from every node in this connected component, you should be able to reach every other node in the same connected component, okay? From 0 I can reach 2, I can reach 1. Similarly, from 1 I can reach the other two nodes, and so on, right? So that is a connected component. In this case, if you see, even 3 is a connected component, okay? And we can say 5 is also a separate component, though it is not connected to anything else, but in this node in itself is a connected component, okay? As simple as that. So now the other most important part is, see, they are talking about something called a complete, okay? They are saying like we can add the word complete to the connected component to make it as a connected component, complete connected component. When there is a very peculiar definition here, you have to be very careful. Let's see, a connected component is said to be complete if there exists an edge between every pair of its vertices, okay? For example, in this case, if you see, 0 is connected to 1 and 2, okay? It has to be connected, okay? Let me do one more example. See, in the example number 2, if you see, in this, okay, I'm talking about 3 4 and 5, okay? Obviously, like there exists a path from each node to every other node in this component, that is true. But in this case, if you see, 4 and 5 are not connected. But if you see the definition mandates that there has to exist an edge between every pair of vertices. So in this case, 4 and 5 belongs to the same component, but that doesn't exist an edge between them, okay? Remember, you can indirectly go from 4 towards 5, okay? Through 3 you can go from 4 towards 5, okay? Similarly, the vice versa, from 5 you can come to 4 through through 3. But the idea here is there is no direct edge between 4 and 5. For that reason, 3 4 and 5 are not, it cannot be called as a complete connected component. They are a connected component, but they are not a complete connected component, okay? As simple as that. So I hope now you understood the reason, okay? And one important part is, if you see, they're very clearly saying this point, that there will not be any repeated edges, okay? Remember, obviously there will be cycles, because if you see that definition of the connected complete connected component, okay, there has to be cycle, okay? As you can see, 0 1 and 2 are basically in a cycle, so cycles will be there. But very important point they are highlighting here is there will no repeated edges, okay? Which basically takes us to the idea of in order, okay? That is how to, if we have the in order, for example, if you see here, in this case, if it is 0 1 and 2, okay, like if a 0 has to be connected to every other node of this component, obviously we know what is the in order of it going to be. Since it is mandated that none of the edges will be repeated, for example, 0 to 1, there has to be only single edge, okay? There cannot be more than one edges from 0 to 1 directly, okay? So because of that reason, it's very clear that just with the using in order, see, in order means this one, okay? In yesterday's question we have used the same, okay? I expect you to go and read the yesterday's question. In order to do a topological sort, basically we need the graph and we need the in order of every node in that, okay? Same concept we are going to use in today's question also. Using these two, we'll be solving it, okay? So let us see how we are doing it. So first of all, yeah, I'm creating answer node, okay? This obviously, like this will show the number of complete connected components, and finally we're writing this as the answer, okay? As you can see here. Other than that, if you see, we are storing three other things, okay? What are the three other things? See, first is the visitor nodes, okay? This will tell us which are nodes we have already visited, okay? That is, when we are exploring a particular component, see, for example, if you see in this, we are starting from zero, let us say, okay, we are starting from zero and going towards five. So when I start with zero, I got to know that, okay, this zero is a part of a connector component in which the other nodes are one and two. Okay, so I will not process one and two separately, because one and two will also processed along with zero, because they all belong to the same component. Okay, so that is a basic idea. For that reason, we need a, set to know which all sets, which all nodes are already visited. Okay, in a global level. So this will be a visited nodes. Okay, this will be a set. Other than that, we need a graph, because see, we are given some edges to, in order to store those edges, so that I can, anytime whenever I'm in some edge or in some node, I can know where the other edges and nodes for this. So for knowing that, I need a graph. Okay, and similarly, they're in order. Okay, in order will, for each node, it will basically tell how many, edges are, coming towards it. Okay, see, this is a bidirectional graph, so there is not pointed edges, remember that. But still, for example, if it is 0 and 1, okay, this particular edge between 0 and 1 will act as an incoming edge for 0 also, and similarly it will as an incoming edge for 1 also. Okay, it's either way, it's a bidirectional kind of edge. Okay, as simple as that. So first of all, I'm processing all the edges that we are given. So what I'm doing, in graph of I, I'm appending j. Okay, so what that means is, from I can go to j. Okay, that's what I'm trying to show. From in the I as a key, I'm, remember, this is a list. Okay, this is a list. Remember that. So in that list, I'm just appending j. Similarly, in graph of j, I'm appending I. Okay, so these two are kind of a vice versa of each other. In graph of I'm appending j, in graph of j, I'm appending I. Okay. Other than that, if you see, if in both the cases, okay, I and j, for each of the in orders, I'm, just incrementing them by one. Okay, I'm printing the graph in order. I will show you the. Okay, let me first show you that, and then we will go for the rest. Okay, so if you see, this is how it is looking. So basically, this is the graph. Okay, in this case, if you see, 0 has adds to us 1 and 2. Similarly, 1 has adds to us 0 and 2, and so on. Okay, and other than that, this is the, the in order. Okay, in this case, if you see, 0 has an order of 2. As you can see, 0 has, 2 edges around it, so it has an order of 2. Similarly, 1 and 2 also have in order of 2. So, okay, 3 and 4 have in order of 1. As simple as that. Okay, so in this case, if you see, 3 and 4 have in order of 1. Okay, because there is only one edge coming towards 4. Okay, coming and going towards 4. Okay, as simple as that. So now coming to the rest of the code. See, this was just, a starting part. How to do the rest? See, very simple. Since you have to go through each of the nodes, this is the follow up I'm using. This follow up will go from 0 to n minus 1. Okay, now if this I is already visited, okay, this I, exists in the visited nodes, then I have to simply continue. Okay, as simple as that. If that is not the case, only then the rest of the code will be executed. Okay, what is the rest of the code? First, we will include I in the visitor nodes set. Okay, this is done. Okay, remember, this visitor node set acts at a global level. Okay, this will act as a global, set variable. Okay, other than that, why I'm saying this specifically is that, because we are again going to use another set which will be, acting as a component level. I will show you that. Okay, so this part is done. Okay, now we are going to create another node. Okay, we are going to create another set. Okay, that is called nodes in current component. Okay, that is also going to be a set. In that set, I'm already already including the current component, current index I. Okay, current node I. Okay, so in this particular set, there will be already a component which is I. Okay, similarly, in the, I'm, creating a queue also. In this queue also, there is already existing element I. Okay, now what is this queue for? I will tell you. But the idea is just like a BFS kind of thing that we are going to do now. What idea here is, from 0 we'll trying to see which honors we can visit. Okay, as simple as that. So this basically you can think of as a BFS. Okay, very clearly I'm saying this is going to be BFS. Okay, maybe from this point onwards. Okay, from this point onwards, it is kind of a BFS only. Okay, as simple as that. So we are creating the queue, and yeah, one more thing you will ask me is why I'm creating a DQ. See, DQ, see, you have to import it like this first of all. Okay, so from collections you have to import default dictionary and the DQ. Okay, DQ basically means the double-sided queue. See, because I'm, doing a pop left and I'm doing append. Okay, see, append means it's will be appended towards the right, and I'll pop left means it will pop from the left. Okay, so these are the reasons why I'm using the double-sided dictionary, because, sorry, double-sided queue. Idea here is, we cannot pop left from a list. Okay, it will take over time if you do that. Okay, that is the reason why, if you have to do an over one time, you, from both ends, if you want to insert and pop in over one time, then you have to use a double-sided queue. Okay, that's how we use that. Okay, this is again just a comfort which I'm using with, which I'm going with. It's up to you. If you don't want to use, you can ignore that. But yeah, do not use in a single list. Do not pop from the left, otherwise it will take around over time. Okay, remember that part. You can pop and append both from the right. You can do that, right? Now, once it is popped, okay, this is going to be a current node. So I'm going through all the, adjacent nodes for our current node. Okay, as simple as that. So see, idea is going to be very simple in this. Before being inserted into the queue, it has to be added in the, okay, it has to be added in the set. Okay, this is the logic that we're going to follow. This is the guideline that we're going to follow. Before being added into the queue, the node has to be added to the, this particular set. Okay, so what I'm doing, this node is popped out. I'm going through all the adjacent nodes of the current node. Okay, I'm going through all the adjacent nodes for the current node. Okay, if the adjacent node is not visited already, remember, these are two different extents. Okay, this is a different set, and this is a different set. Okay, this set will tell us in this particular component which all sets we have visited, which all nodes we have visited, and this will lie on the global level. Okay, this has the scope within this particular for loop. Okay, within one iteration of the for loop, this has the scope, but this one has a scope in all the iterations. Okay, as simple as that. So what I'm checking is, if that's a node is not in this. Okay, As simple as that. If that is the case, what I'm doing is, see, now you will ask me, see, now a very clear question will ask me why I'm doing two sets. Okay, this set and this set, why I'm doing that. Okay, I could have used a single set. The reason is, I will tell you in a minute. Please wait. It is coming here. This is where we are needing it. Okay, I will tell you why it is needed. Okay, so please be patient. There is definitely a need. It's not like, I've simply coded it. There is a need. That's why I've used it. Okay, two separate sets. So what I'm doing is, we are going to evaluate some node. If the adjacent node is not already visited in the current component, then I'm adding it to the queue. Okay, remember, it will be added to the queue only if it is not visited already. Okay, even if it is there in the queue, even then we will not add it again into the queue. Okay, simple as that. So we're following the same thing. First we are adding it to the queue. Okay, after that we are adding it to the both the sets. Okay, what is the first set? First set is the visitor node set. Second set is the the nodes in the current component set. Okay, this will be done. This loop will keep continuing till all the nodes are visited. For example, see, if you're starting with 0, 0 and 1 and 2. Okay, these three will be visited. Okay, in a single iteration of this particular for loop. Okay, in a single iteration of the for loop, 0, 1 and 2 will be visited. Okay, simple like that, right? Now what will happen once we are coming out of this while loop? We will have these three things. Okay, we will have this particular set first of all. Okay, this set will tell us in the current component how many nodes are there. Okay, now I will just take the how many it is just the number of the nodes in the current component. Okay, and current comp. Okay, this is the number of nodes in the current component. The length of the nodes in the current component is equal to length of this particular set. Okay, now what I'm doing is, see, for node, see, now I'm going through all the nodes which are there in the current component. Again I'm going through them. Okay, I'm again going through them. Now this time I will check is, if the in order of this particular node is not equal to this particular number minus 1. Okay, why I'm doing this? See, very clear idea. See, in this case, if this is 0, 1 and 2, now number of nodes in this particular component are 3. Okay, do you agree with me? 0, 1 and 2, there are three components in this, sorry, three nodes in this particular component. Okay, connected component. Now for each one of them, 3 minus 1, which is 2, is has to be the in order. Okay, for example, 0 has should have in order of 2. Similarly, 1 should have in order of 2, and 2 should have in order of 2. Why it is like this? See, because we have to follow this. Okay, see, the definition of complete, if you see, they are saying that there has to exist edge from the current node to every other node in the component. Okay, for ensuring that, what you are doing is, since it cannot have edge to itself, that's why we are doing this minus 1. Okay, I will show you here. See, we are doing a minus 1 here. This minus 1 means just to ensure that there is no self kind of edge. Okay, the node does not have edge towards itself. That is the reason why I'm doing a minus 1. And then if the in order of the node is not equal to this, means that in that case we can conclude that this particular connected component is not a complete one. Okay, in that case we have to break out. Okay, if this case that doesn't occur, okay, doesn't occur, that means this whole for loop completes without a break. Then we'll come to the else part and we are incrementing the answer. Remember, in Python, for a whole for loop there exists a else condition. Okay, if you're not aware, please go and study this part. This exists. Okay, this else condition for the for loop will be executed only when the whole for loop has completed successfully. Okay, if this break condition got executed, then this else condition will not get executed. Okay, remember, for a for loop there can be else condition. The idea here is, if the for loop completes successfully, only then the else condition will be executed. I know it sounds a bit, I'm sure that when you are hearing for the first time, you'll think that, okay, this person is saying wrong, but this is the right idea, my friends. This is the right idea. Okay, this is difficult to capture in one go, but this is the true case. Okay, if this whole for loop completes without a break, then this else condition will be executed. If this for loop completes with a break, then this else condition will not be executed. Okay, so idea is very simple. If we are going through all the nodes of the current component, and if we find that, okay, there exists at least one node for which the in order is not equal to n minus 1, that is n means the number of nodes in the current component, that number minus 1. If that is the case, we will not increment the answer by 1. If that is not the case, that that means all the nodes in the current component have in order of number of components in the node, number of nodes in the node minus 1. Okay, in that case we will increment the answer by 1. Okay, as simple as that. Then I'm printing this part for you. Okay, just to show you like what component we identified. Remember, what I'm printing need not be a complete component. Okay, it is just a connected component. Okay, and then I'm writing the answer. So let me quickly show you the outputs now, so that you get a very clear idea what is happening. See, so for the example number 1, okay, here I'm printing the connected components below. See, 0, 1 and 2 forms a single component, 3 and 4 forms a separate connected component, then 5. Okay, remember, these are just the connected components. They need not be complete. Okay, they need not be complete connected component. Okay, so that is why the answer, if you see, it is 3. In this case, all of them are complete connected component. Okay, let us go to the second example. In the second example, if you see, okay, there are basically two components, 0, 1 and 2, and 3, 4 and 5. Okay, out of them only 0, 1 and 2 is basically complete connected component, so we are writing only one as the answer. We are not writing 2, because see, here there are two connected components, but out of them only one is a complete connected component, so one is going to be the answer. Okay, as simple as that. So yep, that was all for this particular question, friends. See, it is very simple. We are using in order to is ascertain that in a connected component, in a single connected component, okay, each node has a edge to the other node or not, to ensure that, okay, we are using this in order concept. Okay, how I got this idea? I got the idea because of yesterday's question. I have done yesterday's question using the same approach. Remember, whenever you're trying to do the topological sort, you will have to take this approach, because this is a very good way of doing it. You just need the graph and just need the in order way. Okay, with that you will be able to do the topological sort. Okay, And same thing we are following here. This is not a direct topological sort, but yeah, we are getting some ideas from it. Okay, so the idea here is that if a particular node has a order value of a particular value, that is, if the any node in the connector component has a order value of the number of nodes in the component minus one, okay, number of nodes in the component minus one, then each node should have that. First of all, if that is the case, then yeah, we can say the current connector component is a complete one. Okay, as simple as that. And finally we bring the answer. So yeah, often that was all for this particular video. And when you're submitting, comment out these print statements, and please do let me know how you felt about this question. When you saw this question, how you felt, what approach you tried first, and then how you were able to solve it ultimately. So please do share those information with us, because that will be something really good for everyone. Because how everyone tackles the question for the first time, that really, it's very important. That will give us an idea like where, in which direction we are thinking. Okay, those directions are very important, friends. Believe me, in an interview, if you are going in a wrong direction, let us say the interview is 45 minutes. If you are going in a wrong direction, that means at least 10 minutes, or at least 7, 10, 12, something like that minutes are going away. Okay, because they are going in a wrong direction. That's why I always say, first discuss the idea with the interviewer. If you have a pen and paper, like if this is kind of a live interview where you're physically present in the interview room, then take a pen and paper and start showing what your approach is in a just in a pen and paper or in a blackboard. Just show them the approach. If they agree with that, they will obviously ask some questions, but if they agree with that, only then start the coding part. Okay, it's very important that you first convince them, okay, this approach can work. Okay, obviously if it is not going to work, or if you're needing some hints, then obviously you can ask that also, right? But again, it's very bad thing if you start simply coding and later you got to know that, okay, this is not the right way. Believe me, see, it's not just about whether you can code or not. Okay, that's not, coding a solution. You will, for example, in a maths equation, right, in a maths problem, if you get the final answer, that will only add 1 or 2 marks. Okay, but rest of the mark depends on how what steps you are showing. Okay, what complete steps you are showing or not. Okay, as simple as that. So there are marks for that also, remember that. Okay, so ultimate code is fine, but you have to show the how you are getting approaching the question, whether you are properly asking the follow-up questions. I mean, see, when you are given a question, it may not be the complete one. Okay, for example, the constraint that I mentioned here may not be mentioned in interview. So you will have to ask those things. Okay, whether there will be repeat edges or not. Okay, what will be the length of the n? Okay, those things you have to ask, so that you can design a proper solution. Okay, because let us say if it is n is around 10 power 5. Okay, then you cannot go for an n square approach. Okay, a simple O of n square approach, you cannot go for that. Okay, similarly, if n is very small, let us say 20 or 30, then you can go for a O of n square approach also, because that will be really suitable for it. Okay, so see, when people select you, right, in a interview, they expect someone who can face the customers. Okay, ultimately, see, every company is learning from the customers. You should be able to present your solution. You should be able to ask whatever questions from the customer directly. Okay, or whoever is like the requester for the particular problem. Okay, so that's why, friends, see, always learn the business aspect of it also. See, coding is fine, but you have to be in a presentable way. Okay, you have to present that also. Okay, just knowing coding is not enough. Obviously coding is a must, but with that you have to develop your soft skills. With that you have to develop projects. With that you have to develop your communication skills. Okay, only then it will be of some use. Okay, remember, see, there are many people who know a lot, but they are not able to write everything in during the rest. Okay, that's the reason why knowing is not enough. You will even have to write it. Okay, so till you are getting that interview, like you are getting selected, till then you have to keep trying these things. Okay, as simple as that. So yeah, friends, that was all for this particular video. I tried my best to explain this concept. See, the graph week is starting now. As I mentioned, whenever we reach the end of the month, at least the graph week, or the DP or the trees week. Okay, any one of these three will be coming, and we are ultimately reaching that. We even had a hard question some time back, and obviously when we are reaching the end of the month, we will have multiple more hard questions. And obviously today Sunday, Sunday is coming. Mostly for Sunday, they give you a hard problem in the last week. So let us see if that comes or not. So yeah, that was all for this particular video, and I have completed my 150 days, and this was my 151st day. And if you like my solutions, please do subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.